What's up, Spiceheads? Thanks for hanging out with us for today's webinar, Protect Your Network with VMware NSX and MicroAge, brought to you by MicroAge and VMware. Before we get started, I want to remind everyone this webinar is being recorded. If you have to step out, you'll get an email with a link to the video later on today to watch it on demand. Also, there's a Q&A box on your screen, and I encourage you to submit your questions at any time during the presentation. If we're not able to get your question live, someone will be able to follow up with you. And as usual, we also have a live chat, so join in by clicking on that widget at the bottom of your screen if it's not already open. Now let's get started. Today's presenters are Thanos Siotis, VMware Channel Sales Engineer for NSX, and Perry Peterson, Director of Practice Management for MicroAge. So Perry, whenever you're ready, take it away.
What an introduction, Emily. Thank you to come out and listen to Thanos and I speak today. We really appreciate it. We love bringing cool technology to the front, like VMware NSX. To get it kicked off, we'll do a little bit about MicroAge presentation. Can everybody hear me well? Give me 1 second here. I apologize. Okay, everyone, so we'll give a brief overview of MicroAge, who we are, and then talk a little bit about the practice management division, which I'm part of here. So MicroAge, who are we and what do we do? We're a reseller based out of Tempe, Arizona, and we service everything from the desktop to the data center and everything in between. We've been in the industry for 40 plus years, so we have a lot of experience, and with that, we've had a lot of trials and tribulations. We were founded in 1976 by Jeff McKeever, and we've had a couple different iterations of our organization. We were originally founded as a computer hobby store, and then later grew into a billion-dollar distributor, and then reemerged as a value-added reseller. We love it because seeing technology really from its birth to today has just been amazing. And then, with Jeff McKeever still being involved in the organization, it really just brings a lot of credibility to what we do and then how we go about our business. I think for those of you who have maybe worked with us in the past, and for those that hopefully will work with us in the future, we approach our business a little bit differently than your typical reseller. I'm part of a division, practice management division, and really what we are is we're subject matter experts for different areas of the data center. We actually get the really cool job of turning the nerve knobs and testing the technology to see if it's actually going to be something you guys could use or if it's, hey, the latest and greatest trend that's going to get bought and die a couple years later. We're all familiar with that, and unfortunately it's all too common. But really what my team does is we take an objective approach to how we work with you guys. We're not going to be a Cisco shop. We're not going to be a VMware shop. We're not going to be an HPE shop. We're really going to look at the technology, what it brings to the table, and then evaluate how you can implement that into your environment. Now, that being said, we're not agnostic, but we are objective. When we find awesome technologies like VMware NSX, this is something we really want to bring to the forefront because we think it can change the way you guys do business. And I think as you listen to Thanos' presentation, you'll start to get that feeling. It's starting to make the hybrid cloud, the hybrid cloud movement an actual reality for you guys. Be able to extend your work from an on-premise environment to an off-premise environment and beyond, and then take advantage of multiple cloud providers. The beauty of cloud is that everybody does something better than another person, and each cloud provider is going to be specialized. So thinking that you can pick one to rule them all is not quite going to work. Where we specialize is a few areas of the data center. So from our perspective, we really have focus areas, and we feel like this really encompasses the majority of the data center. Virtualization being probably one of the biggest and most disruptive technologies we've seen in the last 10 years. When we look at virtualization, we're not only talking about the compute aspect, but we're also starting to think about the storage, the networking, and then extending that to the desktop with end-user computing. So really what we want to do is make your organization agile and able to meet the demands of the business. And I know that's a commonly used phrase and probably overused, but I think it really does speak volumes into what you guys are dealing with on a daily basis. Deploying an application, making sure that server is going to work for you. Those are the days of old, right? We're really competing with the cloud providers on a daily basis, and you guys specifically are feeling the pressure from probably the C-level down, and then as well as from the end users. So we really just want to help you kind of navigate this field. There's too much out there to really do yourself, and that's where we come into play, where we specialize in different areas. We all work with one another, and again, you're never going to find us pushing a product on you. We're more about the education, and then even when we come to capabilities as far as demoing or just getting some hands-on use, we do have our own built in-house lab that we can extend to you guys and then walk you through some of that. We really feel like we approach it differently. We're not gonna wear the vendor shirts on a daily basis and push that down your throat. And I think that kind of takes me to my next point, which is really what I think differentiates us, as well as the MicroAge values. If you look at kind of the bullet points at the bottom, my favorite is have fun and do it right the first time. I think these are key to doing business. If you're not having fun, you're not going to enjoy yourself. And then doing it right the first time is just making sure that you guys, when you implement a solution, you're not going to have to answer to why that didn't work out, or why you made that investment and it didn't bring the ROI that you expected. We want to make sure that we make that something that never happens for you guys. We want you guys to have a great experience each and every time you work with MicroAge. And if we can't do it, we're going to let you know, and we're going to get you to a partner that can do it. So rest assured that when you come to us, it's not going to be a sales pitch 9 times out of 10. It's going to be a conversation about technology, because that's what we love to do. When we look at our partnerships outside of VMware, you can see that we do support and have relationships with the major IT manufacturers today: Dell, Cisco, HPE, Lenovo, Microsoft, HP, VMware, EMC. The list goes on. This is just a small snippet of who we support and who we have relationships with. So when we talk about being objective, we really are. We have the ability to facilitate any of these solutions, and we have great relationships. So from your perspective, that comes down to a support. From a support aspect, we can always assist with those issues. But then even from a pricing as well as architecture standpoint, we're going to be able to bring the resources to bear for you guys. So really, it's something we wear a lot of hats, but we enjoy doing it. Now, when we look at MicroAge as a whole, these are kind of some just bragging rights for us, right? Ranked 161 on the CRN Solution Provider 500, named to the CRN Tech Elite 250 for the second year in a row, 2016 Microsoft USB Champions Club West Renewal and Annuity Partner of the Year. So we do have some of the clout, and you can see that we're very invested in making sure that we understand the technology and work with the partners so that you guys can get the best possible solutions. The big thing I'm into is let's connect socially. Guys, we're on Spiceworks. I've been part of the Spiceworks community for a couple of years now, and it's something that's pretty awesome from my perspective to see you guys actually discuss the technology in an objective manner. When we deal with our clients a lot, I think there's defensive posture that's put up quite often because they feel like they're being sold, and the Spiceworks community has given us the opportunity to really just answer questions and then talk technology with you guys. We do host and support the local Spice Corps initiative here in the Phoenix area, and that's just taking our engagement with you guys to the next level, whether it be going out and doing go-kart racing, whether we're doing Dave and Buster's events, or whether we're doing any other type of event. It's just great to get out and meet you guys and get to learn about you as people. I think from a sales perspective, we always think of dollars and cents, and this really changes the game for us. So I appreciate your time, and I appreciate you letting us present to you guys today. And I think without further ado, I'll turn it over to Thanos. Before doing so, though, I just want to say, when you guys listen to this, think about NSX and how it can affect your business, not only from a networking perspective, but from a micro-segmentation perspective. When we look at security, it's probably being pushed to the forefront more than anything. With breaches occurring left and right, malware probably has hit your business or is a concern of yours. So definitely, think about how this may be implemented. And as you do have questions, Thanos and I will be more than happy to answer those. But without further ado, I'll turn the mic over.
Thank you, Perry. Good morning, everybody. Let me check the slide. go. So good morning. My name is Thanos Siutas. I'm a channel system engineer for the US West region, and I work in the networking and security business unit of VMware. So this is a technical presentation, not too deep dive, but kind of like an overview of what is NSX and what are the use cases, and of course, giving the most of the emphasis on the security and the micro-segmentation part of it. So as you can see, the agenda, it's the three main use cases. We've seen customers deploying NSX in the field, and then we'll leave some time at the end for the Q&A, which I'm sure you will have. So about the data center, I mean, you may think, okay, what is NSX? Why do we need it? Should we care about it? So let's take a first, a look at the data center. The data center exists for a single purpose, to serve applications to the users. Now, these applications, in order to run, they depend on compute, storage, and networking and security. Now, the last couple of decades, maybe 1 decade, we had the compute and storage be having lots of evolution with virtualization. So we have vSphere in the terms of compute. We have vSAN or hyperconverged storage solutions for storage. But in terms of networking, really the only thing we've seen across the market is going from 1 gig to 10 gig, maybe 40 gig, 100 gig in the future. So just the layer one speed. And okay, maybe went from telnet to SSH. But really, this is, apart from some other complicated protocols, this is mostly what has been done the last few years. And this is a place where it didn't actually evolve to catch up with the pace of businesses. And when I say the pace, I mean for the new cloud-native applications with cloud deployment of applications, hybrid cloud or public clouds. So now the way we deploy and create applications, it's not as it used to be like 20 years ago. So the servers are now virtualized. The VMs can actually be mobile. They can move around. They're not in a fixed place. But networking expects them to be in a fixed place. So security expects them to be at a specific place. So this part of the data center has not evolved over these years. So that was part of the success of when we launched NSX 3+ years ago. It was because the market was needing a product like this. So
Hey, Thanos?
NSX, yes?
Can you speak up just a bit? We're having a bit of difficulty hearing you on the line.
Oh, okay. Is that any better now?
That's a little bit better, yes.
Okay, then. Apologies for that. So what NSX provides actually is a reproduction of networking and security functionality. So we do provide switching, routing, load balancing, firewalling in software. So this is network and security virtualization. It's not SDN. I mean, the way I see it, SDN is just a software way to manage and set up physical devices. We don't deal with physical devices. So now the same way you used to do and you do today, when you deploy virtual machines, it's all part of software. You don't touch any physical device. You just have the definition of a virtual machine. It's all a folder, files. It's the same thing with network virtualization, because now you can put in a template, a software template, the definition of the VM, the switching, the routing, balancing, firewalling, and then deploy these applications anywhere you like, and you can then delete them, and you also delete what you actually have set up for the networking and the security too. So nothing, with leftovers like in the traditional security firewalls where people delete applications, but they don't tell that to the security guys. Firewalling rules keep getting longer and longer and bigger in terms of numbers. So, and let me give you the 3x3 matrix of the customer use cases. By the way, this is not something we have come up for the use cases of NSX. This is what we've seen customers use it today in their data centers. So the main three pillars is micro-segmentation security, automation, a way to create your own public cloud and deploy everything in an automated way without any manual intervention. And then application continuity, disaster recovery, network pooling, all these kind of things. So these are the three main pillars of use cases. And of course, the first one will be the security part. Now, before I jump into the security part, let me give you an overview of what is NSX, how does it look like in the data center and the hypervisor. Now, as you can see, we have the server, the storage, and the traditional switching at the underlay. But what we've done with NSX is that we have added extra code in the hypervisor, so vSphere hypervisor. And now we have given the ability for the vSphere hypervisor to be able to do firewalling, load balancing, switching, and routing in that hypervisor. Now, by doing that, and by deploying this kind of functionality in a cluster of hypervisors in the data center, we have created a distributed platform to deploy the services. Now, and this is also giving us the ability to have high throughput rates, because each one of the hypervisors adds to the speeds and the functionality of the cluster itself. So someone might say, you know what, hypervisor cannot be, it's an x86 box. It can be as fast as the biggest firewalls or routers or switches, which is true, but that's one box. If you have a cluster of 10 of them, then you multiply the performance by 10 collectively. So that gives you high throughput rates. It provides east-west, as we call it, firewalling. So VM to VM data traffic, now you can firewall it. Even if it is in the same IP subnet, the same VLAN or logical switch, you can firewall it. Traditional firewalls, they only do VLAN to VLAN firewalling. So we'll see how that works in just a few minutes. So as I said, in a data center, what you have is at the bottom of this slide is the existing network infrastructure. You don't need to change, upgrade it, put something new in it. We support any IP fabric. All we need is IP connectivity from end to end. And if you do logical switching and routing, we expect an increased MTU of 1600 bytes. That's all. On top of it, so you configure once, that's the MTU. And then on top of it, once you install NSX in the vSphere hypervisors, you can actually deploy applications like the ones you see on this slide, single tier, multi-tier, complex, simple applications with the firewalling, the load balancing, the routing, and the switching. And this can be done in software. So since we can do this in software, we can actually create all these using a cloud management platform. Now, that could be virtualized automation from VMware. It could be OpenStack. We have a product that utilizes OpenStack with NSX, or anything you like. Someone could use scripts or create their own cloud management platform to deploy these applications using the APIs of NSX. So this is the way to scale this in the data center. And by the way, once you create all these things with automation, you can do the same thing and reverse it and delete these applications. You also delete with them the switching, the routing, and the firewalling that was being created for them. So nothing left behind as a setup. How do you deploy NSX? It's not complicated, and I believe that's also a part of the success of the product in the data centers today, because the steps to deploy NSX in a data center is very simple as that. You deploy NSX Manager, which is just a virtual appliance. It's an OVA, as we call it. You connect it and register with vCenter, and then you just deploy a cluster of 3 NSX controllers. This is the control plane, by the way, the control plane of the logical switching and routing. It's similar to, if I may, to the comparison to a supervisor of a modular switch, layer 2, layer 3 switch. That's the equivalent. And then you just deploy NSX in the clusters. So, and this is done per cluster. Now, because this is code going into the hypervisor kernel, it's new functionality. Nothing gets disrupted. There's no reboot required. So this is a huge thing. You can actually deploy NSX per cluster. You don't have to deploy it everywhere, but you may choose 1, 2, 3, 4, 5 clusters as you see fit, and no reboot required. So you can start migrating your VMs to the logical switches or just apply firewall rules immediately. Now, let me give you a very quick view of the logical switching and routing. How does that happen with NSX before we move into the main topic of security? I mean, how do you communicate? How do you connect all these VMs that used to be connected on VLANs? Now we call them logical switches. It's the same theory. We don't change the TCP/IP stack. The VMs connect to a virtual NIC. They connect to a logical switch the same way they connected to a port group in vSphere. Nothing changes there. But now what we do is that we utilize VXLAN. So when a VM, like a VM1 on the left, wants to send a layer 2 frame to VM2 on the other hypervisor, what happens is that now we take the packets to a special port group in the hypervisor, so that is NSX handling it, and we encapsulate the packet into VXLAN, which is an IP UDP packet, actually. So since it's a UDP packet, we can send it over to the other hypervisor. It will remove the encapsulation and deliver the layer 2 frame to the other VM. And this is the basic, let's say, high level of communication between VMs using VXLAN as an overlay above the IP fabric. And this is why I said we need IP fabric, IP end-to-end, because once we encapsulate that layer 2 frame into an IP packet, then IP communication is all we need. So the X letter, the second X in VXLAN is extending actually the VLAN, a layer 2 subnet, across layer 3. So that makes it quite powerful because now we can actually deploy VMs and subnets across the data center or data centers over the WAN, simply because we can rely on IP communications. We don't need layer 2 adjacency. So nothing changes in the way we design and deploy applications, because in terms of the logical connectivity, the logical view of an application, it looks like the same thing, even if we have VLANs and physical routers. So in this example, you have the web logical switch on top, the application logical switch at the bottom, connecting to a router entity. Now, those used to be a VLAN for the web and a VLAN for the application, connecting. So they were connecting to a physical layer 3 device. But now, all the elements are software. So this is a logical switch. Don't get confused. This is the same IP subnet, the same IP things apply. And then this is a logical router at the right, connecting these two logical switches. So nothing special or different in the way you used to do networking. Now, the way it looks in layer 3, when you do logical routing, is that we do not rely on the physical network today to do the routing of the layer 2 switching. Because we have all the connectivity, we have all the topology of the network of the VMs. We know where each VM is. So when a VM, let's say the green VM1 on the left, wants to send a packet to the blue VM5 on the other end, and as you can see, the hypervisors are on different IP subnets to demonstrate that we can actually send it over layer 3. Then the packet goes to the logical router, which is that part, that circle part of the hypervisor, and then the logical router will say, "Oh, this goes to the blue logical switch, so I will switch it. I will route it to the blue logical switch, and then the packet will leave the hypervisor, will go to the other hypervisor, and will be delivered to the blue VM5." Now that's quite powerful because we did that without consulting, if you will, the layer 3 routing of the physical devices at the bottom. And we have the logic, and we take all these layer 2 and layer 3 decisions in NSX. Now, a nice side effect is that if you want to send a packet from the green VM1 on the left to the blue VM4 on the left, which is on the same hypervisor, previously you would have to send the packet to the physical network to do the routing, and then get the packet back to the same hypervisor to deliver it to VM4. But now we can do that within the kernel of the hypervisor. And as you can see, we can also do the firewalling there. So even if there's a communication from VM1 to VM4 on the left in the same hypervisor, we will do the firewalling, we will do the routing and switching at the same time in the kernel. So that is this is quite powerful, and this is the east-west optimization of traffic and firewalling that I spoke earlier. Now going to the firewalling, the security use case, which I guess we all need to hear about. Let me give you an idea of the micro-segmentation options we have as a use case within NSX. Now, what you can do with NSX is you can completely isolate networks, and you can have as many as you want, and you can completely isolate them, no communications whatsoever. You can segment them and create a micro-segmentation topology, and this is like a 3-tier application in the middle, web application database. And you can say that, I permit specific traffic from the web going to the application, from the application to the database. So I control and firewall the traffic moving in between those segments or within those segments. So I can create a single firewall rule saying that VMs in the web logical switch should not be talking to each other, like drop all traffic. Simple as that. Same segment, no communication whatsoever. I mean, web servers should not be talking to each other. And then on the right, you see that we have also the ability with advanced services, because we have an API that we connect with third-party services like Palo Alto, Symantec, McAfee, Trend Micro, all these checkpoints to provide advanced security services. Because what we do in the kernel is simply put, the traditional 5-tuple firewall. We don't do guest introspection like antivirus. We don't do deep packet inspection. We don't do IPS IDS. So we rely on those vendors to connect via the API and provide this within the same hypervisor without using external devices. Let me give you the details on that. So guest introspection That's one of the things you can actually do in terms of security with NSX. So what we do is you have a guest VM, the application operating system, and each VM has a VM tools deployed in it. So let's say that we have a virus infecting that the operating system or the application, and what we do is we redirect from VM tools the traffic of going to the file system of this VM to the guest introspection service VM. It could be Trend Micro, it could be Symantec, Checkpoint, to do all this antivirus and malware detection in the guest VM. So now you have all these capabilities natively and without any agent running in the guest VM. So this is optimized for maximum, speed and efficiency. Plus, if there's a hacking of the guest VM, well, guess what? The first thing I will disable if I'm in the guest VM, I will disable the antivirus. I will disable the any in-guest firewall module. I mean, this is one of the other things that people say that, yeah, I have an antivirus agent in there, and I also have a firewall in the operating system. Well, guess what? If I break in from a permitted application port, well, these are the first things I will disable. And then without any issue, I will try to move my way into other servers too. So this is something they cannot bypass. They have, we control this communication to the data system, the data file system, so we will redirect the traffic. Now, moving on, apart from the antivirus malware, this is the NSX distributed firewall. This is a very, very powerful firewall. It's a stateful firewall. It's not access control list. It's a stateful firewall in the kernel of the hypervisor. It's not a VM. It's in the kernel. And that's why we can actually get line rates, so 20 plus gigabps per host, which is like 10 gigabits in firewall, 10 gigabits out firewall. And you can do more than that if you have the 40 gig line cards in the host. We have been able to go up to 35, 36 gigabits per second on these line cards. Now, as I said earlier, people will say, yes, but I need a firewall which is like 100 gigabits. Well, you may need it today because what you do is you send all the VLAN traffic up north to this big, huge firewall to firewall the traffic, and then the traffic will come down again to the VMs. And that's why you need 20, 40, 50, 100 gigabits of firewall. It's not because you have 100 gigabits internet connection. I mean, maybe you have a gigabit or maybe a few gigabits, but not 100 usually. So what if we do this in the kernel of the hypervisor? If you have a cluster of 10 hosts, you will get up to 200 gigabits with 10 gigabit line cards. You can get 200 gigabps of firewall communication. And this is huge. The more hosts you add, because you need to scale the applications, you immediately get more performance for the NSX functionality. Now, this is a layer 2 to layer 4 firewall. So yes, we can actually do firewalling based on the MAC addresses of the VMs. And then on the source IP and destination IP plus the port level of the application. And the way it works, just to give you some kind of animation, from the NSX manager where you have the user interface of the firewall, we communicate and send over a message bus the root table to the ESXi hosts, and that actually gets into that green DFW firewall box in the middle, in between the VM and the actual switching, the virtual switch. So as you can see, the firewall is like each VM has its own firewall at the virtual network interface card. And this is in kernel space. The VM or the user using it cannot bypass that firewall. Okay? the VNIC will send the packets out or receive packets through that VNIC, it has to go through the DFW, the distributed firewall, even before it goes to the switching or routing or whatever. So this is extremely powerful. This is the best place to actually set up your firewalling policies in the kernel. And this is why we don't care about the topology, the connectivity of the VMs, because we can firewall the packets in and out of every VM. We don't care if it's the same subnet with the other VMs. We will firewall. And now you've seen guest introspection, you've seen the firewalling, and now let's see the network introspection, as we call it, which is like advanced security services. So what we can do is firewall, but what if you want specific traffic redirected for deep packet inspection or IPS, IDS, to check for application firewalling capabilities? What we can do is that we can mark, or you can mark this traffic in the firewall rules to redirect it to a services VM from a partner. Palo Alto, McAfee, Symantec, Checkpoint, they all have products that work with NSX. And as you can see at the top, NSX Manager will connect with a partner management console, let's say Panorama for Palo Alto, and we will exchange the security groups, the elements, the components that need to be firewalled and need further inspection. And in that case, as you can see at the bottom, the traffic over the VNIC goes through the firewall. So we will do the network, the guest introspection. We'll do the green block in there. We will do the firewalling, the distributed firewall, and then we will say to the service VM, take a look at this traffic because it's interesting. Maybe you need to look at the payload. Maybe it's an attack. Maybe the user uses port 80 to do peer-to-peer networking, to do Skype, anything that they shouldn't be doing. So this is the way it works. And you can do all these in parallel. You don't have to do one or the other. So you can have the guest introspection, you can have the DFW, and then you can have the network introspection done in parallel for specific VMs and specific traffic. As I said, it's not all or nothing. You can combine the services and you can pick and choose any option you like. And as you've seen, that was done inside the hypervisor. So each hypervisor you choose to protect with these services will have these service VMs in that box, ESXi host. So the traffic will not leave that host. Okay. So we apply security closest to the VM, to the workload. Now, just a small view of how this policy, this security policy would look like in the user interface. So as you can see with this pop-up, when you create a security policy, in the number 2, 3, and 4, you have the options that I just described to set up the guest introspection services, or you can name them like antivirus, the firewall rules, which is the distributed firewall rules, and then network introspection, or in other language, it's the advanced security services like deep packet inspection, IPS, IDS, and so on and so forth. So this is how it looks like, guest introspection services. We have added 2 rules to apply VMware data security, and this is a service that we're looking at flat files for PCI data, HIPAA, credit cards, all these things. And then as a step 2, we will send the traffic, the file block traffic of the VM to the McAfee Move antivirus engine. And then the next step is the firewalling rules. And we say that, this VM has a specific policy that, for having the source of this VM, the destination could be any, service any, block, permit, whatever, or we can put specific policy in there. you can have a long list of firewalling rules for this specific VM. And then, of course, out of those firewalling rules, you may have one that says if that VM connects to the application VM on port, say, 8443, then redirect that traffic to the Palo Alto Networks engine for further inspection if the payload is indeed what the user is supposed to send to this VM. So you can do this while you create a security policy for the VMs in the data center. And just to give you a more holistic view, this is how NSX secures the software-defined data center, as we like to call it. So you have the hypervisors across the data center, and then you have the NSX installed. You have distributed firewalls. So you see all these nice red blocks of firewall in the kernel, and then you have the VMs on top of it with their own green square on top of them being the firewall policy we apply to each one of them. And then the way they all connect is by using what we call an NSX Edge service gateway, and this is a VM form factor logical router, but that also has a perimeter firewall. So you can actually firewall these applications, traditional firewall, interface, IP subnet firewall with the NSX edges, and then inside the data center, you can also do the DFW, guest introspection, and all this stuff. Having said that, you see there's a dotted line from the virtual to the physical. You still see the perimeter firewall, the physical on top of all these, and then the wide area network or the internet. Well, we don't replace the existing perimeter firewalls. I mean, usually these boxes have more capabilities. They can do IDS-IPS, denial of service, and we free resources from them because we do the firewalling inside the data center. So what you can actually do is keep them. Now you will have more capacity since we do the firewalling to enable more features that usually would take up more CPU and memory, and you didn't have the luxury of doing so. So you continue to keep them. I mean, this is the edge firewall of the entire data center. You need to have it there anyway. Okay. The way we do firewalling, indirectly, we will give you more bandwidth there, available bandwidth. So the next time you replace it, refresh it, you could pick a smaller box. Smaller means cheaper. So this is how it looks like in the secure data center. Now, just to give you an application of how it may seem like a complicated example, but this is an everyday example that we see in data centers, and this is how micro-segmentation simplifies network security. Simplifies in a way that even if I'm not a security expert, when I look into the firewalling policies and rules, I can immediately understand what they do. Okay, it's not cryptic language anymore. And the good part is that this is true because we use objects from vCenter. So when we group VMs in the sense of, let's say, HIPAA or PCI or whatever VMs as an application, we can name them as HIPAA or PCI, and we can provide firewalling rules saying that any communication from the HIPAA applications, the HIPAA VMs, cannot initiate a connection to the PCI system or the engineering or the internet or whatever. And this is easy to understand. And let me give you an example of how you have these logical switches today, the web tier, the application database, and of course the shared services at the bottom. The way we can actually do it is that we can create a security group, and a security group is just the objects, VMs, that we protect. And we can create, in this example, 4 security groups. The web, application database, and then the services group. And we can protect and we can say that the web tier should be able to talk only to the application tier, plus accept connections from the outside on a specific port. and of course, access the shared services to get Active Directory authentication, NTP, DHCP, whatever, DNS. Now, you can see that they have different colors. You have the red, green, and blue. So they may belong to different groups. So maybe I have the first, the three, the red ones, maybe the web application database that belong to the HIPAA application. The next, the green ones could be from belonging to HR or development or engineering, and the blue ones to the payment system, PCI DSS protected compliance. And you see that I have them in the same logical switches, or could be VLANs, but I need to protect them. So what I can do is create those vertical security groups, the red, orange, green, and blue, and I can create security policy rules that say those applications, the HIPAA security group, can only talk to each other. So even if they belong to the same, like the web tier or the application tier, they cannot cross talk with each other, only their own security group. So I can have this granularity and isolate these applications from one another, even if they connect to the same network, even if they exist in the same cluster of ESXi hosts. I no longer have the need to create different clusters, create a different isolated DMZ zone or PCI or whatever. You can have them, and this is according to the regulations and the compliance documentation. We have documentation from Qualifier, which is an auditor, and actually will give you, there's a document online that will give you the detail on how this is possible, even for an audit to pass with NSX. Now, this is a compliance reference architecture, and you can see on the left all the authorities, PCI, HIPAA, NIST, and you can see on the right the VMware or partner products that can actually help with the auditing and the compliance and the regulations to make it happen in the data center, in the software data center. And because this is something we hear a lot from customers and partners, that are these, firewalling and this isolation and micro-segmentation that NSX provides, are they fulfilling, are they, according to those security regulations like PCI DSS and HIPAA and all the others? Yes, they are. It is approved by auditors, and if your auditor is kind of like behind in terms of technology, because to be honest, we've seen sometimes auditors not being able to easily grasp how virtualization works. So they would demand that you even isolate the ESXi host with physical networks and even storage and all this stuff. Well, now we can actually prove with the technology that it can be done even in the same clusters, even in the same hosts. So moving forward with this is the micro-segmentation. This is the security part, the micro-segmentation, which is, to be honest, one of the biggest use cases with NSX, because it does apply with all companies, even the smallest ones. They may not have the need to, like, as I will show a couple of slides for automation. They may not need the automation part, kind of like creating their own cloud. Maybe they have like 10 ESXi hosts, they have like 10, 20 VLANs, and this is static. They don't create new VLANs, they don't have a dynamic environment, but they do require to have PCI compliance and isolation for their applications. They may require to have, maybe in the medical sector, they need to have HIPAA compliance and all these. So while they have a static environment in terms of networking, the security aspect is paramount. So they need this kind of functionality. And this is why we've seen many, many customers actually utilizing NSX simply for the security part of it. And then, of course, you can grow, you have the functionality to grow more on the uses of NSX. So in terms of automation, and that includes, of course, the automation about security, there are tools today like serialized automation or OpenStack, or you can even run your own script if you like. You can deploy an application like the one you see on the slide, which is a typical example of three-tier application, along with the firewalling, the load balancing, and the routing. You can put this in a template. You can describe it in a template, and you can deploy with a click of a button. So you can say that, you know what, I have an application. Maybe this is a traditional, Linux LAMP stack, and you deploy to do the demo or the testing of the new version of the application. Now, you also have the ability to reuse the same IP subnets while you do that. So this is the kind of isolation we provide. You can part of the edge services VM that I was talking about. We can provide NAT functionality. So you can deploy the same IP subnets, the same VMs with the same IP addresses, and then on top of them put a layer 3 device that does NAT. And you can replicate that as many times as you like with the same IP addresses. They will not, interfere with the other elements in the network. So this is powerful. And by doing this, you actually save enormous amount of time instead of waiting for the switches, the routers, the firewalls, or maybe even the load balancers to be set up. You just click, and then you immediately work in minutes. And why do you do that in minutes? Well, simply because everything is in the software. It's pre-approved, it's pre-designed, it's put in a template, and now you just click, and once you get the approval, everything starts to build up. The VMs using the traditional vCenter API, and then the networking and the security. So there you go. Everything automated. And by the way, when I go back as an administrator of that application that I just requested, I can say delete application because it served its purpose. I've done my testing, I've done my versioning, all is good, delete that environment. It will delete, it will reverse, it will delete the VMs, it will also delete the networking setup of any VMs created for the perimeter security, the routing, and the firewalling, everything. Now for application continuity, what do I mean with application continuity? It does refer to having multiple data centers, minimum of 2, of course. You can have them as an active standby or an active-active, as in this example. So you have 2 data centers with NSX, both sides vCenters, and then you have a global load balancing service at the top. So you can actually select where you redirect the traffic. Both data centers are active. They have applications active in both data centers. Or you can have this one as a standby at the right. So if the one on the left fails, you can fail with NSX, you can fail the applications to the right, and then work from the DR side. Now, what is the biggest plus having NSX? Well, since we do the logical switching and we don't rely on the physical hardware, the physical networking hardware, what you can do in the logical switches is keep the same IP addresses both ways. So you fail over to the right data center, and then the applications, they get to keep their IP addresses. Okay, so no DNS changes, no VLANs, because the firewall rules, the distributed firewall we use is in the kernel. It's like vMotion, it goes with the VM. So guess what? When you move those VMs, not only they keep the MAC addresses and the IP addresses, they also have the firewalling rules in place immediately. So your security profile is intact, your networking is intact, no DNS changes, no firewalling changes. It's just we enable the routing from the other data center, and you're back in business. Okay, so this is quite a fast way to do disaster recovery to another data center, and we have the ability to do that, as you can see on this one, from 1 up to 8 vCenters plus data centers today. So you can connect them all seamlessly, and you can create the controller cluster in one of them, the primary and the secondaries, up to 7 secondaries. You can have what we call the universal. Let me show that. So what we have is the universal logical switches extending across those vCenters, those data centers. Okay, and the only thing we require, of course, is the over the wide area network. If you want to extend the logical switching to have the increased MTU on 1600 bytes, and then you can move VMs. You can have applications on the same IP subnet across different data centers. And for the VMs, it's the same thing. They have no visibility on things that happen underneath. So let me give you now the last few slides with the use cases, as I said, and of course the pricing. So this is the solution use cases: security, IT automation, application continuity. I don't know if you know the 3 tiers of licensing of NSX, but this is the feature set and the licensing, and on top you see the list price, which doesn't include the subscription, the support and subscription. But this is today the list pricing per physical socket of the servers you install in NSX. As I said, you can do that per cluster in the data center. So if you have a vCenter with 5 clusters and you only want to do micro-segmentation, for example, in one of those clusters, because this is where you have the PCI application or the HIPAA or whatever, and these are like 5 hosts in one cluster, then you only need 5 hosts times, I think it's times 2 physical sockets. This is the most common server I've seen out there. So 10 CPU license of the advanced, the middle one, the advanced license. And this is just the list price. So what you can see, the standard providing the logical switching and routing, the advanced providing the standard plus the security and the firewalling, and then the enterprise license, the most expensive one, provides the previous slide you've seen, the cross vCenter, multi-site NSX connectivity, and of course integration with other stuff. But this is the most expensive. We have multiple data centers, and you want to connect them together in an active-active and create logical switching across them, then you need the enterprise. Most of the customers actually need the advanced, but enterprise is there for the bigger customers with multiple data centers. Now, this is the last slide actually showing you the adoption in the field. As I said, it's more than 3 years out there, so it's not let's say a technology that will disappear. The adoption is quite fast. So this slide shows you data from the third quarter of 2016, so more than 3 months old. We had 1,900 customers. That represents 100% of year-over-year growth, and of course a huge increase in license bookings. Now, we have customers. Initially, we had customers from the financial sector, the government, the big ones, because the big ones had the biggest problems to solve, and NSX was there to solve it. But then gradually, after that moved, after the first couple of years, we've seen smaller customers entering that use of NSX because of the value they find there. So you're not the first ones. If you deploy this, you're not the first ones to actually use NSX. So this concludes my presentation, and I've included a very, very nice URL. This is the bit.ly NSX-doc. And if you go there, this is a public space on VMware.com that has documentation, design guides, reference guides, with even with hardware like blades and switches from companies, micro-segmentation. It even has security micro-segmentation benchmarking, if you will, from Coalfire, an auditor, about how to use and how do you present the compliance, the security compliance with NSX. So bookmark it. This is coming from the business unit. Lots of nice documentation there. And I have two other booklets, PDF booklets that you can find online about network virtualization and micro-segmentation, what they actually mean, how they look, how they operate. So this is all from me. And if you have any questions, this is the right time to ask them.
Yeah, let's go ahead and answer these questions quickly. We've run over time, but let's get these two questions answered. Matt would like to know, are the SPI firewall throughput numbers dependent upon available computing power?
So yes, I mean, everything that runs in software is depending on available computing power. So if a customer, let's say, for example, has an ESXi host without NSX at 90%, well, I would say that this is a quite stressed host. We would say that you need to add more hosts to kind of like balance the load. But honestly, it's just like 2 or 3% of the overall CPU capacity of any server today. So nothing spectacular. I mean, even those 20 gigs per host of firewall performance will not take more than 2 or 3%, because remember, this is a stateful firewall. So apart from the initial lookup in the firewall table, it's just then if it's a session already in place, we don't take the packets, the next packets through the firewall. We check the hash table, the session is there, we'll send the packet immediately. So not an issue.
All right. Fantastic. Can NSX implement a load balancer across different hosts in different locations that are all tied to a single vCenter?
So yes, we can load balance. I mean, we have two load balancers. One is the distributed one, which is in tech preview in the kernel, and the other one is by the NSX Edge VM form factor. So that one can be the load balancer, and the VMs can actually be and should be in different hosts. They could be in different locations too, because if that edge connects to the logical switches, well, as I said, the logical switches can extend over in different locations as long as there is IP connectivity. So yes, you can absolutely do that.
All right, fantastic. So we are out of time and out of questions. Do you have any final words for our audience, Thomas?
Use NSX. At least learn about it. Try it online. We have the hands-on labs that are free out there, and they can test it, they can play with it, they can break it. It's all open and free, and then decide if it makes sense for them.
All right, fantastic. Perry, anything to add for you?
Once again, thanks everybody for joining us, letting us spend some time with you today. I know the exciting inauguration was going on, so hopefully this was well worth your time. We look forward to continue to engage with you guys. For those of you who are based in the Phoenix area, definitely keep an eye out for our Spice Core events. We'd love to have you join us. That group continues to grow, and we love hanging out with you. So again, thank you very much.
All right, fantastic. Thank you so much. Want to remind everyone that if you had to step out or miss any part of this event, you will be getting an email later on today with a link to view the webinar on demand. Special thanks to both VMware and MicroAge for sponsoring today's event and creating today's content, and thanks to each and every one of you for tuning in today. We hope to see you back soon for another Spiceworks Partner webinar. But until then, stay safe and keep it spicy.